Hey guys, my name is Carlos Hernandez, and today I wanted to go over a little bit of a tutorial over what a man-in-the-middle attack really is. We've heard about this a lot in the hacking community, and as a network engineer or a regular person studying networking or ethical hacking or security engineering may know, man-in-the-middle attack is basically when a PC is intercepting between two other PCs or between a PC and a router and is trying to intercept the traffic so that they can see it or extract it for their own use. So let's go ahead and get started. But first of all, let me go ahead and mention that this is not going to be done through black hat hacking. We're going to be doing this as white hat hackers, because today we're going to be going ahead and doing this for Dr. Pon's EEL 4789 class, which is ethical hacking in FIU. So this is the purpose of this video, but let's go ahead and get started with this tutorial because I think it's going to be a little bit interesting and I hope you guys enjoy it. Let's go ahead and get started. Alright, so what is a man-in-the-middle attack? A man-in-the-middle attack can basically be seen as, I spoke to you before, as when a PC gets in between two other PCs, or a PC gets in between a PC and a router. So in this example here, for instance, we would go ahead, we have PC1 and we have PC3. So PC1 has an ARP table. This ARP table usually would include all the other devices that are in that network. For the purpose of this, I'm just going to show PC1. Even though PC1 wouldn't be in its own ARP table, I'm just showing you this so you can see what the IP of PC1 would be. But let's say the real ARP table would have PC3 in this scenario, if it is on its network, and the router, which is the default gateway in this scenario, which would also be on its network, along with any other devices that could be there. Now, PC3 is directly connected to the router, and it's having internet connectivity, so it does see the router, and it does see its MAC address. As well as I'm putting PC3's IP and MAC address here, even though it wouldn't be on its own ARP table, but we would go ahead and see it here, so that we can, for demonstration purposes. So what do we have here? Right here is what the connectivity these two would be. So the router would usually be in between these two, or a switch, for instance. But in this scenario, there is a man in the middle. Literally, there is someone that's trying to attack or intercept the connection or the traffic that is occurring between these two computers, or these two PCs for that matter. Now, this PC will usually have, obviously, an IP address as well as a MAC address. And how it works is that this PC, which is PC2, take out PC3's MAC address and put itself in place of that MAC address. So let's go ahead and see that you guys can have a little bit of a better idea. So as we see here, PC3's MAC address was changed to what PC2's MAC address was. Now, PC2 needs to get in the middle of these two so that any ARP response or any ARP reply that's occurring is going to be going through PC2. So when PC1 is sending traffic to PC3, for instance, it will now be going directly to PC2. When traffic is going from PC1 to the router, it will now be going to PC2, and vice versa with PC3. If it's getting ARP request or it's trying to send any kind of traffic to PC1, it will see PC2 will be intercepting that traffic, and they will have access to monitor that traffic as it goes. So now that we can have a little bit of a breakdown on what that is, let me go ahead and explain to you the tools that we're going to use today so that we can go ahead and perform this attack. So first of all, we're going to be using these tools in Kali Linux. Kali Linux is an operating system that was developed by Linux so that we can have all packages or all applications in one single package, so that we can use it for ethical hacking use or for any kind of hacking. So first we're going to use EtherCap, which basically would sniff the live connections that are occurring throughout, meaning traffic. We can use filter content. So we can use EtherCap for that. It basically works like an ARP spoof, which we can also go into as well. ARP spoofing is basically just you doing the same thing as EtherCap would be doing. Another tool that we will be using is driftnet. Now driftnet, what it does, it captures all the pictures that are being seen between the two PCs or between the PC and the router. Whatever it's seeing on its computer, the man in the middle, which would be what we would be doing today, would be seeing that traffic or those pictures that are being sent. There's also another tool which is quite useful. It's called sslstrip. Now what this tool does, it removes the S from the HTTPS websites, which makes it unsecure. So what the typical user would be seeing when there's a man in the middle attack, they would be seeing basically a notification that keeps telling them that this website is insecure. The website is insecure. The website is insecure. So when you see this, you're basically going to see, if you have a couple of minutes and you understand what's happening, you would see that you're being basically getting your SSL stripped. If you keep on seeing the same message, the same website, that's exactly what will happen. So that's what we're going to do with SSL strip. Now URL snarf is another tool that we can also use and we'll be using, which is basically whenever the PC that we're attacking, which in this scenario we're going to call PC1, you're going to any URL, whatever that may be, then the URLs that you're visiting will be seen by the man in the middle in this scenario, which would be us using Kali Linux. And lastly, we're also going to be using Wireshark. Now Wireshark, as most of you may know, it can sniff packets basically. So for this scenario, what we're going to do is we're going to sniff the login credentials of someone trying to log into a specific website, and maybe some other information that we may find along the way. So let's go ahead and get started with the actual meat of this presentation or tutorial. Let's go ahead and move into our virtual machine. So we're going to log in. Now, this is Kali Linux. Most of you may know, if you're into ethical hacking or if you enjoy open source programs, you might have heard of Kali Linux. Now we're going to be using Kali Linux to go ahead and perform this attack. So as I mentioned, you can use it using Ettercap or you can use it using ARPspoof. So we're going to use Ettercap for this scenario. So let's go ahead and get that started. So you're going to do Ettercap-G. What this would do is basically bring up the GUI of what Ettercap is basically allowing you to do. So let's go ahead and click enter, and we're in. So as I mentioned, Ettercap can be used for packet sniffing and specifically unified sniffing. So that's exactly what we're going to use it for today. So we're going to do unified sniffing, which is basically just going through a specific port of your network card. And in this scenario, we're going to be using ETH0. So we're using ETH0. Now we're going to go to host. We're going to go to scan for host to see which hosts are available. Right. So now that we scan for the host, we're going to go to the host list. Now that we see the host list, we can pick specifically which targets we're going to pick. Now in this scenario, .5 is what we're going to use as our router per se. So let's go ahead and click that so we can add it as a target for target 1. Once we do that, we can go ahead and scroll down. And the IP that we're going to use, as you saw on the image that we were looking at before on the PowerPoint, is .148. That is a XP computer that we will be going ahead and testing this tool on, or doing a man-in-the-middle attack on. So let's go ahead and get to that. Let's see here, 148, there we are. So we're going to add that to target 2. This up. So we're going to go to MITM, go to ARP poisoning, click sniff remote connections, which is exactly what we're doing. We're just sniffing for remote connections on ETH0. So let's go ahead and do that. So as you see here, we have group 1 and group 2. Group 1 being the .5, which is the default gateway in this scenario, and .148, which is our second host, or the host that we're going to be attacking. So let's go ahead and start officially, start sniffing. And it already started. So let's minimize this little guy over here. So what I want to show you now is basically what you could do if you were to go ahead and want to see images that you're seeing on your computer. or on the person's computer that's you're attacking or being as a man in the middle. What that would be like. Just give me 1 second. I'll open another terminal over here, and we will go ahead and do drift. No caps, of course. driftnet -I and ETH0. ETH0 again, the same interface that we were using before, so we're going to go ahead and grab it from there. So now we see nothing because that what XP is visiting nothing. But what if we go to the XP machine? So let's go to the XP machine and let's go on the internet and let's just click, well, Leonardo DiCaprio did win that Oscar, so let's go ahead. I want to read a little bit about that. So let's see here, some other news. Alright. Oh, that's pretty tough. Alright. So, what happened here? So on the Kali machine, what you're seeing here is every single image that was being seen on that PC, on that browser, rather on the PC that they were browsing, is literally showing up here. Every single image. That could mean anything really. Let's say you're trying to see what your girlfriend is seeing and you're trying to perform a man in the middle attack. You can literally just go ahead and do this and see everything that that person is seeing, which is pretty intrusive and crazy how easy it can really be. So more images keep popping up because that that browser is loading, and if you keep on going and you scroll down, you can see all those images that we found using. Keep on going. Let's see if Leo shows up eventually. He should. So let's see if he shows up. Not yet. Not yet. As long as it took him to win that Oscar is as long as it's gonna take to show him up here. But let's see how it looks. If it looks up. Okay, so it seems like it didn't show Leo, but that's okay. Because what we can do now is, instead of seeing it live, we can also save all these images using driftnet -I ETH0 again, do /-d, and you do /root and save it to my images. So it's gonna basically create a directory called my images on the root. So now that we're done with driftnet, let's open another tool that I was talking to you guys about. So let's do URLs-nar, which basically just grabs all the URLs that that other person is seeing on their other PC. So let's go ahead and do that. We'll do URLs-nar -I ETH0. Basically the same way that you would do that on driftnet, you're going to do it on URLs-nar. So let's go ahead and do that. Now it's listening on ETH0. Let's go ahead and open up our machine again here and see what would happen if we see all the different links that we were seeing previously. So let's go ahead and check back and see. So now that we ran the URLs-nar tool, we can go ahead and see all the different URLs or links that the person on the XP machine was visiting. So as you know, we were looking at the MSN website, we were looking at specific links through that MSN website, so let's go ahead and open one of them specifically. So we can literally, as easy as pie, we can just right click on the link and it directs us to iceweasel, which is the browser that we use in Kali Linux. And we can literally see the same exact thing or the same exact link that the person was seeing. So you can just imagine how easy that could be, or the amount of URLs that people can visit that you can literally sniff or see what they're seeing. So let's go ahead and minimize that window. As you know, we see all these different links since we were clicking on several different parts of the website, which is what we see here. So let's go ahead and just Control-C that. In fact, we can even see the one we just looked at. So on iceweasel, we were looking at MSN, so we can also sniff our own traffic. It's also sniffing our own traffic since it's going through that same interface. So that's why we're seeing that. Alright, so now I want to go in, a little bit into Wireshark. We're going to be using Wireshark so that we can sniff the login credentials from a specific website. We're going to try that, and then we're going to see how it works and see if we're successful. So stick by so we can go ahead and do that. Now let's open Wireshark. We're going to go to Applications, go to Internet, and click on Wireshark. So as I was mentioning, you're going to get this, just press OK. As I was mentioning, you would basically, by doing this, just select your interface and capture every single packet that's going through that interface. Specifically in this scenario, it's also going to take what's on our .148, which is the XP machine, and it's going to grab it, and we're going to see everything that's going to that machine or that person is visiting. So let's go ahead and start the capture. Now that's going to take, let's just go ahead and go to the XP machine so we can go to a specific website. So let's go to testfire.net, which is a test site which portrays a bank website. It has several different links that can be tried to test vulnerabilities and penetration attacks. So let's go ahead and go to the login, and let's type just Carlos and then password that I wouldn't want someone to see. So that's a pretty long password. Let's see if we just log in. Let's remember it. Obviously I'm not logged into this website, so it's going to fail. But if we go back to Wireshark in Kali and we stop the capture, we can go ahead. Now since we're here, we can literally see sniff on that traffic. Since we were using HTTP or the HTTP protocol on port 80, we can just type HTTP. Now HTTP is basically going to show you everything that's running that protocol, which will be everything that's on the browser and that person is viewing on the internet. So let's go ahead and find specifically the testfire website that we were looking at. So this is a get, but we're specifically looking for a post which is going to show us the text that is running on that website. So let's go ahead. There we go. There's post. Now we click on this, go down to line-based text data. And what do we see here? That person's username, which as you saw, I tried, which was Carlos, and the password, which we put hacking is the best 123 because it is. That is, we easily were able to find what that login was by just going to Wireshark, checking specifically the packets that were running, and since that website was unsecure and it did not have HTTPS, we were able to see the password and the username with a couple of seconds by just digging deeper. Now we do see this password and we are able to see the username, but this doesn't mean that, let's say, if the person that was seeing your Wireshark capture on their side, since they also are able to do that, if they do have Wireshark, then they're able to sniff their own traffic or sniff the traffic that the network is on, then they would be able to see this, which is why a man-in-the-middle attack is not necessarily discreet, for lack of a better word. So in this scenario, checking Wireshark, we can actually see that this ARP poisoning is actually very loud and it's easily detectable, which is specifically happens when a computer is not taken off the network. So this will cause duplicate ARP replies or ARP entries, and the router is actually going to complain when this happens. This is due to when the ARP packets are sent every few seconds. It would be super easy to get a very detailed record of when that ARP poisoning is happening, or what network it happened on and how long it lasted, etc. So I'm going to show you guys here how we can even see that we're getting a duplicate IP address every time that we're doing this ARP. So let me go ahead and show you here. Let's go ahead and type ARP. Now when we click on ARP, you see here, this is literally telling us right now a duplicate IP address has been detected for 10.106.130.5, which is the default gateway that we were using, and for the 148, which is the PC that we were using to attack. So this means that literally if they were trying to see this traffic, or if the person that is being behind this attack is trying to see this traffic, they would be easily spotting it by just looking at their Wireshark, because it's telling them there's literally a duplicate use of their IP address being used at the moment. So which is why, as we can see, a man-in-the-middle attack, or ARP poisoning per se, which is basically what we're doing here with this attack, is not something that's non-detectable. In fact, it's a very active scan, and not it's picked up by a lot of detection systems that are existing out there at the moment. Now that we know that this attack is very easily detectable, we can also have some countermeasures against it. One of the main ones is using HTTPS as your browser, so that you don't have HTTP, which is not safe. When we typed that website that we were using, for example, on that Windows XP machine. Now most websites do this automatically, so that they don't run into this problem. But for example, some websites still don't use that, which is an example of what we used here today. For example, we would have to type an actual S at the end of HTTPS so it can be secure. But as we were able to go ahead and log into it or take information from it, the URLs, the pictures, everything that we saw previously, it was because it also didn't have an S at the end of HTTP. However, there is something we can use to strip this S of websites that are using HTTPS, or that automatically use HTTPS rather than it being typed manually. And this is something we like to call sslstrip. Now, how sslstrip works is basically transparently hijacking the HTTP session, and every single time there's an HTTPS redirect or an automatic HTTPS link, it's going to turn it into an HTTPS equivalent, which basically just allows the attacker to force itself into that PC that it's in the middle of, and it gets HTTP connections rather than HTTPS connections. So it affects links and redirects. But if you actually type an S after the website, then it wouldn't actually work. So let's put this to the test and use sslstrip as the last tool of this tutorial. Let me go ahead and start that up over here. Just give me 1 second. So we open up another terminal, and basically what we're going to do now is set up a firewall rule that's going to search for any traffic that's going to port 80, which is the HTTP port, and redirect that port so it goes to the sslstrip that it's listening on. So let's go ahead and do an IP tables rule with Kali Linux. Let's do IP tables-t net for some network address translation. Then we do -a pre-routing. We do -p for the port. TCP. We put the destination port, which in this scenario it would be port 80 that we're getting the destination from, and we are redirecting it to port, so we do redirect so that we can put it to port 6666, which is the sslstrip port. So that went in fine. If we want to confirm that the IP tables was able to go ahead and grab that rule that we just added, we can just do IP tables --list -t and then do nat towards the end so we can see the table. Alright, so basically here you can see that it's redirecting the port from anywhere, so it goes to the 666, which is the sslstrip port, since we spoke about earlier. Let's go ahead and now we're going to start the sslstrip process. Let's go ahead and do that. sslstrip -l and 6, and this is going to basically run the sslstrip process or service that, so we can go ahead and grab the SSL strips from our target computer, in the scenario that being PC1, which is the XP. Now I had run this command before, so you're gonna see an error, but the way that you're gonna be able to see it is you're gonna see that it's gonna tell you that the process is currently running. So since that process is currently running, we're gonna go ahead, as you can see here, it's already in use. So let me just show you how this would work. We're gonna open up our browser here, then we're gonna try to go to, let's say, a secure website. A secure website, in that scenario being Facebook, for example, which automatically puts itself in HTTPS mode. So here we go. It gives you the notification here that it cannot be viewed or changed by users, but it says there's a problem with the site certificate. Why is there a problem with the site certificate if there should go straight using HTTPS? Well, this is because we used an SSL strip. It's going to keep on giving you this security certificate problem every single time that you try to go into this website. So for example, I go ahead and click that I do want to proceed. Yes, I do want to proceed. So let me go to Facebook. Come on. So here we go. Now, it went into the website. However, it gave you the security alert again. So what the security alert is doing, a man-in-the-middle attack is also being worked through when you're using SSL strip, as we know. So for example, let's say the end user or PC1 in this scenario is trying to connect through the man-in-the-middle or the attacker. Now this man-in-the-middle, which is us right now using the Kali machine, we're able to establish the SSL session with the Nintendo website. This Nintendo website being facebook.com, for instance. Now, the website is going to respond with an SSL certificate, which is exactly what we saw. It says that there's an SSL certificate, and we needed to go ahead and accept the certificate. So we went ahead and accepted it. Now, a fraudulent lookalike of the certificate was delivered to the end user. That wasn't the original certificate. It's not a certificate that you will see from facebook.com. It's a fraudulent certificate that you will keep on seeing over and over and over and over again, due to the man-in-the-middle being able to insert himself to the client directly. So, as you see, we're in, but this security certificate is still asking you if you want to proceed. You want to proceed. And it's going to keep on telling you the same thing. If we go ahead and view the certificate, it would basically be just a fraudulent lookalike of what a real certificate would look. So let's go ahead and wait and see what that certificate would look like. Alright, so here we are. Basically, it's telling you that it's issued by DigiCerts, High Assurance CA-3. It gives you the details and everything, version numbers, if you ever want to go through that, the certification path, and everything. However, this is only a lookalike of the actual certificate that you would see if you were in fact trying to go to facebook.com and it was redirecting it to you if you're using HTTP. But since we're using HTTPS SSL strip, we are able to strip that S, to figuratively strip that S from the website and keep on allowing that security certificate to keep on going through and through and through and through, and asking that PC if they want to keep on using a fraudulent SSL certificate. So guys, that is the main idea of what we want to go ahead and what I wanted to go ahead and speak today about the man-in-the-middle attack. As we know, it's a very vulnerable attack that if you are not protective enough and you don't take the right countermeasures, you don't use manually HTTPS, or make sure that you're not getting any ARP requests or any ARP replies from a specific PC or IP that's not necessarily one in your network or one you know of, then you need to be careful with this man-in-the-middle attack, because it can be done by someone that you may even know that could just go into your network, put itself in the middle, and see everything you're seeing, your pictures, your URLs, your traffic, and even steal your login and passwords using Wireshark like we saw today. So please be careful out there. Make sure that you always use HTTPS, that you always are behind a firewall, and be safe out there, guys. The cyber world is not something that you want to take any high chances with. Thank you guys for watching. I appreciate your time. Have a great day, guys.